Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will show you how to solve differential equation and how to determine the system response of a given differential equation by applying Laplace and inverse Laplace transform. Okay, so let's have a look at the first example here, where you are given this differential equation and you are asked to solve this differential equation. Okay, by solve, it means you have to find f of t. Okay, so to solve this problem, we have to apply the differentiation property of the Laplace transform. So if you still remember, for the differentiation property, we have, let's say x of t. If we do the Laplace transform, we will have x of s. So if we have first order differentiation, let's say dt of x of t, then the Laplace transform, we will have as x of s minus x o. Okay. If we have second order differentiation, d square of dt square x of t, the Laplace transform, we will have s square x of s minus s x of 0 minus x dot of 0. Okay, where these as well as these are the initial conditions. Yeah. So see, if you have a second order differentiation like this, the s here is to the power of 2 as well. Okay. Now let's have a look at this. So here we have second order differentiation, first order differentiation, and no differentiation. Okay, so if we apply this differentiation property to this differential equation, so for the first one, we will have s square f of s minus s f of 0 minus f dot of 0 plus 3 multiplied by the whole thing. Okay, so we have a first order differentiation, so s f of s minus f of 0, okay, plus 2 f of, sorry, this capital F, f of s equals to, now this one, we can apply the Laplace transform table, where if we have E, A, T, U, T, the Laplace transform is 1 over s minus a. And since we have the a here is minus 1, so we will have 1 over s plus 1. Now it says here, all initial conditions are 0. Okay, so here, this is initial conditions, it will be 0. Initial conditions 0. And here also initial conditions 0. So we will have s square f of s minus 3s f of s, sorry, this is plus, and plus 2 f of s equals to 1 over s plus 1. Now if I take out the fs, I will left with s square plus 3s plus 2, 1 over s plus 1. Now this one we can factorize to s plus 1 and s plus 2. Okay, so if I multiply with this s plus 1 over here, I will have f of s 1 over s plus 1 square and s plus 2. So if you look here, it means you have a function, okay, where the denominator have real and repeated roots. Okay, so we can write this one equivalent to k1 over s plus 1 plus k2 over s plus 1 square plus k3 over s plus 2. Okay. So if we multiply, okay, this k1, k2, k3, so that their denominator will be equals to this. So we will have this k1, you need to multiply with s plus 1 and s plus 2. K2, you need to multiply with s plus 2, and k3, you need to multiply with s plus 1 square. So you have the denominator equals to the left hand side of the equation. So now you can write the numerator only, and you expand this and multiply with k1, k2 and k3 respectively. You will have this equation. S plus 2k1 plus k2s plus 2k2 plus k3s square. Okay. Since we have s to the power of 2, the highest order, so we start with s2, s1, s0. So on the left hand side of the equation, we don't have s square, so we have 0 equals to k1, okay, which is here, multiplier for s square, and here you have s square, so you write down the multiplier, so k1 plus k3. Similarly, on the left hand side, you don't have s, so it will be 0 equals to the multiplier of s on this side. So you have 3k1 plus k2 plus 2k3. And here you have 1. So if you solve this equation with 3 unknowns, so you have 3 equations with 3 unknowns, you can use your calculator to solve that. You have k1 equals to minus 1, k2 1, and k3 1. So you will have fs equals to minus 1 over s plus 1 plus k2 is 1, so you have s plus 1 square plus, and again 1, s plus 2. Okay, so if you do the inverse Laplace transform of this individually, you will have f of t minus, this one is the exponential, e minus t, plus this one, okay, is similar to t. The Laplace transform is 1 over s square. However, here you have frequency shifting by minus 1. So you will have te minus t plus this one again exponent e minus 2t. U of t. Okay? So this is the answer to this question. Okay? So this is f of t, the solution to the differential equation. So next, let's have a look at how to solve for a system response using Laplace and inverse Laplace transform. So you are given this differential equation, okay, and you are us to determine the zero input response, okay, of the system described by this differential equation, where you are given initial condition equals to 0 and minus 5. Okay, so again, you can use the differentiation property of the Laplace transform. So here you have a second order differentiation. So if you solve for that, you will have s square ys minus s yo minus y0 dot plus 3. This is a first order differentiation, so you have s ys minus y of 0 plus 2 ys equals to first order differentiation, so you will have s x of s minus x of 0. Okay. So you are given y of 0 equals to 0, the initial condition. So this part you will have 0, and this part you will have 0. So you are left with s square ys minus 5, so it will be plus 5 plus 3s ys plus 2ys. If I take the ys out, you are left with s square plus 3s plus 2 plus 5 equals to minus x of 0. Now at this point, okay, we know that for zero input response, it means that the input, okay, which is the x of s, equals to 0. Okay, so this part here, which is representing the input, is equals to 0. Okay, so you will have ys s square plus 3s plus 2. This minus 5, you take it there, you will have minus 5. Okay, so ys minus 5 s square plus 3s plus 2. Okay, which is equivalent to minus 5 s plus 1 or s plus 2. Okay, so you have real and repeated roots. So you will have here k1 over s plus 1 plus k2 over s plus 2. If you solve this, okay, you will get k1 equals to minus 5 and k2 equals to 5. Okay, so the fs will be minus 5 1 over s plus 1 and 5 1 over s plus 2. Okay, so the inverse Laplace transform will be minus 5e minus t plus 5e minus 2t u of t. So this is the zero input response, which is FO, okay, of the system described by this differential equation. Okay, so that's all for this video. I will see you in the next one. Thank you.